Now this is a tricky problem. I had to go get help. I made lots of mistakes. I've got 2 pages on what seems like a simple question. I got lots of cross-outs. So let's talk ourselves through this. The amplitude, by the way, is an easy equation. All right, we got a 1 kilogram block of wood. It's attached to a spring. All right, so let's draw a picture. That's not a great color, is it? We've got it's on a spring, and then maybe you'll stretch the spring, and there's a weight on it. What do we know? Okay, we know that the max, it gives an instantaneous speed. So they're giving you the max speed. So V max is 49 centimeters per second. Okay, we know that. And we know that the spring constant K is 13 Newton per meter. And we know the mass of this is 1.1 kilograms. Kilograms? Yeah, it's kilograms. So I want to solve for the amplitude. Now the equation for V max in a spring system, so this is the easy part, is equal to A square root of K over M. We know K, we know M, and we know V max, so we can find A. So you solve for A. That's easy. So question A is easy. Question B is hard. Okay, let's talk about question B. What is the block speed at a point where the amplitude is 40% of the amplitude? So once you know A, you need to calculate it with 40%. Now the way to do this is to use conservation of energy. So walk me through this. So if you remember, total energy, or E total, is the kinetic plus the potential, right? But what's the total energy? When you are at max speed, the total energy, at max speed, there is no potential. You only have kinetic. So if potential is 0, then kinetic is 100%. And so you can say this, total energy would be equal to 1/2 times m times V max squared. And we know V max to be 49. And by the way, as a note, you can leave it in centimeters per second. You can put, it'll work just fine, because if you keep centimeters for everything. So you know the mass, and then you can solve for the energy. And you're going to get a number here, and this is your total energy. Okay? But when we now are at 0.4 of the amplitude, where are we at? So at that point, we have our total energy from here. Let's just call this big J. It's a number, though. It's so many joules or whatever, right? So we have big J, and that's going to be equal to the kinetic energy of the thing. So it's going to be 1/2 times m times, how do I do this? It's going to be equal to, well, the kinetic energy, actually, is equal to, in a spring system, is equal to 1/2 Ka squared. Now A, but you're not going to put in A, like the final A, but 0.4 of A. So whatever A is, which you've solved from here, actually from this equation. So you've got A equals some number right here. So it's actually going to be equal to 1/2 times K times 0.4 A squared. But you also have the potential, pardon me, that's the potential energy. This is the potential energy. This is U. You also are going to have the 1/2 mv squared. Oh yeah. Plus you have the kinetic energy. But if I know what J is, and I can calculate what this is, I can find the kinetic energy, right? So if this is 1,000 and this is 400, 1,000 minus 400, this is 600, right? So once I know that, or you may say K, which you could say that's equal to 1/2 mv squared. So if this J, which is a number, it's not a letter, if this, I know this number, and I know K is something, 13, right? Times 0.4 times A, you got here, equals plus 1/2 m, we know the mass is 1.1, and you're solving for V. This is your question, is what is the final speed at when the amplitude is at 0.4 A? So J is a number, K is a number you know. A is a number you calculated earlier, right? 1/2 m, 1.1 here, and then v, you're solving for v. Or conversely, you could just say, whatever j is minus this, and you say, j minus the potential energy, U, equals 1/2 mv squared. Once you find this, solve for v. There you go.